I think I'm connected. Am I loud?
Yes.
Loudish. Okay. So I still haven't sat down and taken time to play around with the GoPro, figure out why it failed. I'm running a quick test during this to see if, having had my other devices connected to it, when those lost connection, it turned it off. I lost about 10 minutes mid-class, and I still haven't decided if I'm going to post that up or something. On the one hand, it would discourage you from actually attending the class if I always post those up. On the other hand, you don't get as much out of this class if you're not actually here and interacting and me helping you to engage thinking, which is going to be a lot of what I'm going over today with talking about the syllabus and the class structure. And if I put stuff online, then random internet strangers can tell me how bad of a job I did. Just watching that other video did a lot for letting me see things that I did that would annoy me to no end. And I wasn't aware that I was doing, like constantly pacing. I'm not sure if that was distracting or if it kept you guys feeling like you were energetic too. Who knows? But running the recording again, this time I don't have anything to show me what I've actually looked at, and it looks like it's really crooked. So we'll see if it actually runs, and it might be that my first two have no production quality, but I should have everything sorted out by the time we meet again next Wednesday, because 3-day weekend, we don't have class on Monday. I didn't mention lab and lecture are completely divorced from one another. Although I'm the guy in charge of the labs and I'm doing your lecture, so I'm keeping them in mind to a degree. So anything that has to do with the lab, well, you still get to talk to me, but if you take other physics classes, the guy who's teaching the lecture knows nothing about the lab, can't tell you anything about it at all. In my case, I can let you know there are not labs next week or this week, which has already passed for those dates. Labs start on the 26th or the 28th. I think all of our labs are on Tuesday, or they're all on, okay. So the 26th is your guys' first lab. You might get a little bit annoyed because at different points in the semester I'm going to jump in and change what the lab is from what's in the lab book. And that's because right now what the labs are for this class is just the labs in the other classes that aren't as math heavy and seem to get across a lot of concepts really well. They're not really tailored for this class where you are buzzing through material at breakneck pace. Because of the fact we are going through material so quickly, not because I think you guys aren't smart people. This class is a much lower level approach to many things. So a lot of the labs, once I get done changing them, they're going to feel more like you're playing games than like you're really doing strict science. And that's because most games are built on science. Hopefully I'll get around to playing with some of the demos as the semester goes through, which are essentially magic tricks. Because the only difference between a magician and a physicist is that after you watch the magician do something, he doesn't want to tell you how it happened. And after a physicist shows you something, you don't want to hear him tell you for 5 hours what just happened. But in both cases, you're sitting at the edge of the equations, at the fringe of what's possible physically. That point where, unless you do the math, you didn't think it could happen. And so you sit down, you do all the math, you do the tricky engineering, and you pull a rabbit out of a hat type of thing. Now, a lot of other magic is the misdirection, and that's just tied into the whole, I don't want you to know how I really did it, so I'm going to make you look somewhere else for a moment. So I'm going to go ahead and mute this, and we're going to wait to get to the syllabus. And I want to return to what we were doing on Wednesday. Before that completely fades from mind, even though it's now been so long since then that we may have lost a fair chunk of the effect. So I tasked you guys, after we were doing the bouncing the ball, to come up with some tests. And I gave everybody, by counting off around the room, your numbers of what you're supposed to do. So let's get some mass panic now that you've all settled in and you've spread yourselves out. Pick up your stuff and let's rearrange into roughly where our groups were. I think we had 16, so oh dear God, I don't know how exactly that will work. Before people start shuffling, I'm going to try to figure out where on earth I'm going to have you guys meet. There's going to be roughly 5 people per. So we'll go the 1s, the 2s, and the 3s. And then we'll go back 2 rows, so we've got space if we need it, and do 4, 5, 6, back 2 rows, 7, 8, 9, 10, 11, 12, and then I'm out of space, so 13, 14, 15 spread up the top. And 16s, I'll try to finish this quick so you can have a seat. Yeah, if you weren't here on Wednesday, then kind of grab a group that looks like they would be interested in more people, and they'll fill you in as we get time.
You answered my question right there.
People that weren't here, go towards the back, because those groups are going to be short. I don't remember what number we ended on. Wow, we had 6? Okay. Now some of the groups are already starting to do it, but once you get settled in, go ahead and start talking. Not just what test did you come up with, but did you have problems doing so? Remember, you want to trace back to the appeal to authority.
How we were evaluating, like trying to experiment it. How did you
All right, has any group just flat out you've not talked about your testing stuff at all? Because I don't want to dwell too long on this portion. Okay, so I imagine for many of you this was hard. Who thought this was easy and deeply meaningful? Remember, both parts. Because for some of you this was pathetically simple. Okay, this was not necessarily meant to be something easy and deeply meaningful. I'm looking for a point of confusion, because that is a good place to start with teaching people, to show them that there is room in which to be taught. It's very easy for us to dismiss, even if we're not doing it consciously, what we are being exposed to, because we think we know what it's going to be. I'm sure that many of you have dealt with that in just simple conversation. You think you know what the other guy is going to say, you're ready to respond to that thing, they say something totally different, and you start blurting out your response to the wrong thing. Now, normally that's where there's a power dynamic, and they might not challenge you because you're the higher power person. But it's something that happens very easily, and it's something that is a huge problem with starting to get exposed in a new subject, especially a subject like physics, because a lot of physics talks about the day-to-day life that you guys have been living. And this is things you've seen before, but you haven't questioned in depth. And so now we're pushing you to question it in depth. We're trying to get to a point where it's not going to make as much sense anymore. Especially since physics has got a really bad habit of ignoring how the world actually really truly does work in order to get a nice, pretty simple equation, because those nice, pretty simple little equations come out so close to how the world actually does work that they're valuable in messy real-world situations where if you're trying to account for everything, it's flat out impossible. So some things we do will seem, that's not how the world really works. And seeing how those play out and getting that cleared up in your mind is one of the primary goals that I can actually achieve on the timetable of this class. But only for those of you that are coming to me with your confusion. Okay, so who has a test they would like to run? Did anybody come up with a test they'd like to try out?
Where group number 1 bounces, so raise your arm 4 feet off the ground, holding the ball downwards. Drop it, and you observe if it bounces or not. It came back up, so it bounced.
Okay. Do we gain anything worthwhile producing by doing that test? Do I know this ball will always and forever, every time I drop it, bounce?
Not necessarily.
Do I know anything about how it will bounce? If I drop this from the 5th story, let it go all the way down, do I know anything at all about where it will bounce to? Is it possible that someone somewhere who knows everything there is to know about this would be able to tell you what would happen if this was dropped 200 feet up onto concrete, exactly where it would go?
Damn close.
Okay, let's say within 5 feet of where it would go.
Yeah.
How would they ever know that thing? But how do you ever get the equation?
Knowing the forces involved and the angles involved in this.
Did anybody build a test that they think would be capable of leading to at least an element of an equation to describe how this works? And I wouldn't really have expected you to. You guys are not necessarily scientific thinkers yet. And it was a very nebulous task. And we weren't talking scientific testability at this point. The goal with science isn't just to explain what we've seen. Because what you saw is a one-time, it's done, it's gone. Why bother to explain it? The goal of science is to form predictive models. To be able to say, in situation given to you that has not happened yet, what will happen? And that is why scientific testing works. in such strange ways. Because we're trying to make sure that when we make that prediction, we have solid reasoning behind what we have said. So, we're going to go ahead and sacrifice a little bit more time towards this, with now me framing the question better. I want you to find a scientific test, something that can form a predictive element. But first, let's eliminate a few groups. I am sure there's a few up here that there's nothing predictive involved. Let me figure out if I still have colored markers or if I lost them all. Okay, so I'll give you one straight off the bat. Made in China. There's nothing predictive we can do there. We can know if this ball is made in China by looking on it. It says China. That might be the name that they gave this one specific individual ball. That's unlikely. So, what else do we have on here? Instead of taking lots of time for class-wide votes, let's just go ahead and pop out. Who wants to eliminate something? I'm going to eliminate a duplication that we hadn't noticed.
Spherical and up and down are probably two.
Not necessarily. Rock, white. Noise, not necessarily. Confusion, we should probably take out amusing along with that. Rubber, we could do tests since we had a lot more than just the ball. Yeah, friction tests are possible, but friction's something so annoying I don't even like to deal with it. Ground, we're probably not so much going to test if the ground exists today. Okay, so this trims us down to 1, 2, 3, 4, 5, 6. So we've got 1, 2, 3, 4, 5, 6 rows. Okay, that works well. It's not convenient for you guys to all work as a row, though. So let's do clusters. So let's take you guys. So that's group 6 is what you guys were? Okay, good. I did eliminate you. So group 6 will join group 1. And then here we've got 2 and 5, which both still exist. 3 got wiped out, so 3 is going to join 2. 4, 5, 6. Okay, which groups got wiped out? There we go. Okay, so you guys joined here. You guys joined here. So you guys join with the group behind you there. You guys join with the group behind you. And then I've got 2 groups here. So we'll have this group over here come around and join this group. You can sit right behind them. Arizona's group, join the group in front of you. Trying to remember some names. And then back here, was anyone still? No, the back row all got wiped out. So let's aim for the smaller groups. You guys got wiped out, so you'll join right in front of you. And then is the back row, you guys are all 1, or you're 2 groups? Okay, rough size. Someone join over here. So you guys in the back corner, join. I have no idea. Group 7? Okay. You guys got wiped out too. All right, who still doesn't have a group that actually has something testable? Let's have just one person from your group raise their hand. Okay, so I've got 1, 2, 3. You guys have been sent somewhere? Okay, so I've got 1, 2, 3. So you'll come over here. You'll go in the corner there, and you guys will join in the middle there. So I have no idea where I just sent everybody. Groups are probably massively oversized, undersized. We're shuffling the class yet again. But this time, talk about what yours is, how it's testable. If the group is completely stuck after about 2 minutes, ask me, because there is some I forbid you from wiping out. So that means you might not have an idea of how to test it. But remember, we can throw the ball in addition to dropping it.
So we have to come up with a single test?
Just a concept of what a test would look like. So we want to get on the road to building a formula. So frame a test such that it will be able to have predictive power. So we saw the problems with does it bounce? Is there a better way to word that one as an example to lead you towards better testability?
How high it bounces, and then you increase, keep doing it proportional that way.
Yeah, but one of the problems I was having was
So to start with, just spit out anything. I've got a whole group that's all quiet, so just, what do you guys have? You guys have got up, down, which I forbid from being wiped out. So, is it always going to go up, down? When I asked if I dropped this from the 5th floor, would someone be able to predict within about 5 feet? Someone yelled out, well, if they knew, the velocities, the angles, that's kind of the key word towards you guys. Is there something important about the angle? Because up, down makes it sound very linear. How do I know at what angle it's going to bounce? How can I find where to actually catch the thing? If I bounce it off of a wall, that clearly didn't go just up, down. So look along that line. See if you can find something testable in terms of the angles. Okay, this nest here seems kind of, what do you guys have?
Think about whatever you pointed us to.
Okay, which group did I throw you in with?
This group.
Okay, so you guys are in with here, so this is the big up-down cluster, right? You guys are, yeah. All right, so you guys will be talking a little bit loud since you've got 3 rows. This is a huge group. Actually, I'm going to turn you guys around. Join this group, because this is just too many. That's still too many, but at least you can kind of cluster in there. Okay, this group back here is really quiet.
Because I am already confused.
Okay.
We're doing moves on its own, and nothing
Yes.
really moves on its own without force or something being applied to it.
How would you test that? To what degree can it move on its own? When can it move on its own? How does it move when it's moving on its own? Does it ever just flat out move on its own? All right, what do you guys get saddled with? You guys are in with that. Okay. So, yeah, that's what you're looking at is, is this even something well-defined to try testing around? Like the up-down group, they need to reframe theirs to instead be in terms of angles. Now, if you're testing about angles, that's something better. So, once this starts moving, what does it do? If this is sitting still and not moving at all, what does it do? So how do you characterize its motion without anything else touching it? That's when it's on its own. So can you test around that at all? If it is too hard to talk with all of your group, you guys can splinter them to a limited degree. We're not going to be on this for much longer. We're looking for very vague concepts.
steady acceleration that happens at various times, but at one point it will have hit its max acceleration.
Okay, I've got a couple groups that are talking, but I've lost a lot of people. So we're going to bring it back in. Because while this exercise can teach you some things, the main point is just to say there's stuff to be learned. We've got a long journey ahead of us. And I think we're getting that point home pretty well. So we'll carry this through a little bit longer. At this point, does someone have a test they want to go ahead and venture? And you guys can sacrifice someone from your group. If you think your group's got something good, but you don't want to say it, then everybody point your fingers at one guy and force them to be the one who says it. Okay, you've been the sacrificial lamb here.
I have been.
The problem of being outspoken.
Yeah, no, fair enough. Well,
Okay, you guys had bounces.
Up and down, basically. Group 1 and Group 2 kind of were intermingling there, which is okay. But, all that considered.
Okay, they stole your thunder a little bit, but that's good. We can get an argument going. All right, what have we got?
And we were thinking about a test of dropping the rubber ball from various heights onto a level, hard surface. Initially to see the difference in which it bounced depending upon the height you dropped it from. And then doing a few other tests where you test it on a non-level field, where if you have an angled field, to how much it bounces in what direction.
Okay, so we're just going to drop it onto something hard from different heights. Now, how are you going to characterize what that bounce is? And anybody can chime in at this point. So I start with this height, and then what do I measure?
How high it bounces back?
On which bounce?
First.
Or do I count bounces maybe?
Count bounces.
Does it matter if I measure more than just one? Does it get to a point where it's really hard to count exactly how many bounces really were there?
Yes.
What will I be able to compare reliably?
First bounce.
And
Well-
probably the difference in height from where you dropped it to the height of its next bounce, which then you could copy into the next bounce if you did not actually measure it.
Is that something I can safely say? That how it bounces there is the same as how it bounces there?
No.
Because if the speed in which it's falling is the same, then the bounces will always be identical. So if it bounces the first time, it'll go up and we'll gain the exact same speed from that height. So for instance, if you were to drop it from 10 feet first and it bounced 5 feet, then if you were to carry that property over, when it bounced from 5 feet, on the second bounce, it should bounce to 2.5, and then 1 1/4, and then.
Okay, so we've got a supposition that the percentage change will be consistent one to the next. Now, is there a strict difference in what's happening if I release it from, okay, there it bounced about here. So that second time, after it bounced here, it went down and it bounced again. Do you think it's going to have done differently than if I just let go of it right here?
Yes. No. It's hitting the surface and then it's changing how it spins and where it's bouncing up, because it's not necessarily going to perfectly bounce straight up like it did.
Okay.
When you're dropping it.
Will the spin be important to the bounce? Will the spin be important to the bounce's height?
Does it lose velocity compared to like if you drop it from here to if you just drop it from where it bounced?
So at this point, we've already gotten the things can be confusing. How do we break it down? But even after we've pared everything down to a very low point of bounces, and we grabbed up and down and threw that in there, there's all kinds of other factors which may be important. And that's 80% of what physics is all about, is figuring out all of those other factors that may be important. So is it just where I drop it from, or is it how I spin it? Am I trying to characterize absolutely everything about that bounce? I will know how it's spinning, where it gets to, not just in height, but also in position, and how long it will take to do that. Or do I simplify the model? And do I say, all I care about is how high does it get? And that's why a lot of physics feels like it's not the real world, is because that simplification of the model becomes necessary. If we want to check, well, dropping it from here, letting it bounce up to here, and then drop again, and it bounces up to where, is that going to be different after that second bounce than if I let go at that same height as the second bounce? Will this get the same height as this? You have to simplify the models. And then make sure when you say, this is thing I predict, you have to also say how you simplified the model. Because that's the only realm in which your prediction makes any sense. So you say, I think if you drop it from here, it will bounce to here as a height only, regardless of spin, and dropping it from rest. So all of those extra things are parts that a non-scientific mind ignores. It got the important bits. Drop from here, goes to here. I'm done, I check out. That's what newspapers do to science. You see lots of science stuff hit the news, and almost always it's broccoli causes cancer. Scientists found in a research study. But they're trimming out all of there was a loose correlation between people who ate excessive amounts of broccoli and people who got cancer at 20 years later. Note, this correlation was only a 0.5679 correlation, which is insanely weak, but just high enough that there might be something there. Also note that the study sample only focused on people who lived directly under high power lines right next to Hiroshima. Leaving out important bits can sometimes change the whole message. Science, in physics, we try to figure out exactly which ones are the bits that we can drop. We try to keep track of what our assumptions are. And we try to state that clearly when we are showing our predictive model. So as long as you stick within those assumptions, or you make small corrections as appropriate for what those assumptions were, it works. Now you can test some things to see if the assumptions matter. So drop it from here, it bounces to about here. Now I'm going to spin and drop it, and it still bounced to about the same spot. Seeing as how I'm not being very rigorous in exactly where I'm bouncing it, how I'm actually measuring, my tools are crap. So my results are also going to be pretty crap. So you're also straddled by the limitations of your tools. Now, I can erase all that stuff later. We don't need to use time for that now. Okay, so going over the syllabus, the first big thing in there. I said on Wednesday, our course is going to be different from most of what you've done before. And I was approached by someone who had read the syllabus and has done flipped classroom before with concerns. Real quick, how many of you have been in a flipped class before? Not many. Okay, so that's basically what I expected. And the other thing to know, for those of you that have, is that it's a terribly defined concept. So what you do in one flipped class is likely going to be completely different from what you do in another flipped class, because it's not a fully refined model. And some people see it, they translate it their own way, they run with it that way. I'm most likely doing the same thing. But I'm applying my own background in educational theory and psychology and sociology to craft this in the way that will work for learners. What this means is, every week we have 3 hours in this room together. That is when you get my full undivided attention, if you ignore the fact I'm dividing it across all of you. You have me. And supposedly, if the university has not lied to you deeply and hurt you, I'm the expert. So there is value in having me here. If we spend those 3 hours every week with me reading the textbook to you, is that a good use of our time together? How many of you have had a lecture where the guy basically just read the textbook to you? How many of you thought that was the best one ever? So you actually learn from a textbook. It's different for different people. Or they enlivened it, or maybe they wrote their own textbook. It's something that can work, but in the bulk of the times, not so well. What's in the textbook, the basic physics raw facts, it hasn't changed for hundreds of years. The way that we state it is pretty common across the board. So, giving you that, just handing you raw facts, is going to happen out of class. I will assign videos to watch that are between 3 and 12 minutes long. You watch the videos, they get across the facts. The awesome thing about videos is you can pause them, you can replay them, you can watch them more than once, you can rewind and see what that one thing is that he said. You can look for supporting material. You can see more on him. Now there's tons of stuff about physics all over out there. I'm trying to curate from the material I'm aware of what is the most useful for what I'm trying to get across to you. So you need to watch those videos to go through that material that I assign for you. I'll have small write-ups along with them trying to explain what to focus on wherever I possibly can. But then we're going to come into class, and that's when we're going to actually apply it. This is the part normally when they're doing the I'm reading the textbook to you, they dump all this knowledge on you. Then they say, here's your homework, run off, do it, you're done. And so you're on your own with these homework problems that are much harder than anything you actually saw in class. He did the easy examples, and he gave you the hard ones. And you have to figure out on your own, well, how do I get through this? And very often, it's either not graded at all, or it takes so long for it to be graded that when you get the feedback on how you did, the class has moved beyond that material, and that feedback is now useless to you. So that applying the knowledge element is going to happen here, while we are in direct contact, while I can give feedback right away. That is what, for me, flipped classroom means. Now that means if you come to this class, you have confusion about what you saw, or you just didn't watch it at all, and you don't bring that up, there was no point in you being in this room, and it's not doing you any good. Now, if you already know everything about all the physics we do, great. It would have been nice if you used the time to advance yourself further, because there's always something you could have had questions about. But if that's your choice, whoop-de-doo. Now, I don't like grades. I think putting grades in education shifted the focus. People chase the grade instead of chasing the knowledge. For a lot of people, it still loosely correlates to the same thing. You're learning what you have to learn. But for most people, after the test, all that stuff's gone because it's not being graded anymore. For some other people that are doing insanely well, that they're brilliant, and they could push the world to new heights, they see, oh, well, I've got the A, I'm going to stop there. Because the teacher's seen as a grade dispensary, not a knowledge dispensary. But I understand how the real world works. You guys are busy. Life sucks. You're going to get behind. And if there's one class that just doesn't grade you, you don't have to actually do anything, you know you're going to get an A no matter what, they're the ones that are going to get shoved to the side first, because practicality. So there has to be some kind of grades attached still. I'm trying to get a format where you get a grade commensurate with the work that you've done, the work that you've put into learning, to developing, but without putting undue stress so that you're just focused on the grades. So that's mostly what this huge first page goes on about. Grading, I'm going to follow the standard 10% per mark scale, which really is a lie, because that means that half of the work you do is not graded at all, which means half of the points are just going to be given to you for free. So it would be nice if grading scales were actually 0 to 20 is an F, 20 to 40 is a D, 40 to 60 is a C, 60 to 80 is a B, 80 to 100 is an A. Then you're using the whole scale. You're measuring as well as you can. But then people really feel bad, because some days you put in F work and you get 0 points. Well, in this scale, you put in that F work and you get 50 points, because you put your name on a piece of paper. Woohoo! You guys have all had classes like that, where with almost no work, people do get some points. And it's more of a psychological tick than a, I'm using this as an effective evaluation tool. But I'm not fighting against that. That's not the battle here. 75% of your grade is going to be based on 5 of the 7 exams. We're going to have 7 tests. But the tests are not going to be full hour-long tests. They're going to be little half of the class session things. So those of you who have disability support services extended time deals, I need to talk with them to find out if you're supposed to go to a different room, do it with them, because you're going to have to do it off when class time is. When it gets time for the test, then anyone who's got that, I'm going to kick you out of the room, and then you'll go set up whatever time you can with them to do the test. It'll be the second half of class when we do them. And it's going to be an option. When you're taking the test, either you can do a story problem where I present a scenario to you, and you break down all of the physics that's happening in there. I am not looking for a specific breakdown. I'm just giving you an interesting scenario, and you attack it in terms of the physics that we have learned, and tell me everything you can about it. So if we've learned Newton's third law, which is for every action there's an equal and opposite reaction, and I give you a story about crime scene being investigated to see who was the driver at fault for a two-car collision that pushed the cars into a pedestrian and killed the pedestrian. So they really want to know which driver is now guilty of manslaughter. So they need to figure out who hit who. So just looking at the crime scene, thinking in terms of basic Newton's laws, what can you tell me? Now, I'm not expecting that within a half hour you're going to find who the killer is, especially since I haven't told you any of the information you need. I'm expecting you to tell me what you would be looking at, why you think that would be relevant. So you could look for tire skid marks, because why would a tire make skid marks? Well, because the brakes are being applied, because the guy's trying to stop. So if one guy's got skid marks, the other guy doesn't, you know who was trying to stop. You could look at the timing on the stoplights to figure out if there was a stoplight there, which light was red at that point in time. Because you can figure out exactly what the timing is. You can figure out what time the collision happened. You can backtrack if your accuracy is sufficient to tell which light was which. So it's just you are walking your way through physics. You're showing me in general what you know. And that would be graded very subjectively. The other option is there will be a bunch of multiple choice questions on there. 90% of the multiple choice questions, 9 of the 10 questions, will be things that I gave you in homework assignments. Not graded homework, just homework so you can practice and see 9 of the 10 questions. That 10th question is on the same material, but you've not seen anything like it yet. So you choose. Do I want to do the multiple choice, or do I want to do the essay? Or do I write so incredibly fast that I'm going to do them both? And only 5 of your 7 are going to count for you. So first test, you completely bomb it because you chose the wrong option, or because this method of doing the class just doesn't work for you, there's time to recover. Now, in addition to the class, there's 100 of you. I am not going to speak to each one of you on a personal basis unless you come see me in my office hours. So come to my office hours if you have questions, if something confuses you. There is so much more I can tell you than what we do here in class, than what is in those videos. So if this is not working for you, come see me and have your own private class, basically. I'm holding an office hour every day, Monday, Wednesday, Friday. So you can have just as much time in my office hours as in this class. And if you want a strict standard lecture format and there's no one else there with questions, you can use up my entire office hour demanding a strict standard lecture format out of me. So here's the exam dates. Make sure this is on BB Learn so you guys can get it. If you really don't like finding things on computers, I printed off 25 of them up here. Recitation. We have a recitation Wednesdays 4 to 5 in EP 202. You can go there and you can ask somebody else who's not this big scary guy with all these revolutionary ideas and no idea what he's actually talking about. You get a different person. You can say, okay, you're not insane, please talk to me. There's also room 309 in this building. You take the elevator, go up to the 3rd floor, it's practically right there. You go to the right, you hook to the left, and then there's a big conference room. There will be hours for tutors posted there. The tutors are different grad students who teach in different labs, including the one who's teaching your guys' lab. He does have office hours up there. So you can find which one of those tutors speaks your language, and you can work with them. The big point is there are resources. Make use of them. Don't struggle in isolation. Work with your fellow students. At this point, I've shuffled you around so many times, you've got to have met someone else in the class that you didn't know before. Here I list off additional materials. If you are going to insist on learning completely and totally on your own, these are some places you can go that have worthwhile material. Now we're using the OpenStax free textbook, and there is a series on edX from Rice University, which gives you an online walkthrough using that textbook. Now that, and a lot of the videos I'm going to have you watch, are aimed at high school students trying to take the AP exam. Don't feel, oh, this is so bad because it's meant for high school. The AP exam is meant to be equivalent to introductory college level. We are introductory college level. It's exactly the kind of material we should be doing. But the AP exam stresses math heavily because people prepare for that for a year or more because they have an entire year in high school of doing AP level science. And there they meet for almost an hour almost every day. So they have more time than you do. That's why they've got all the hard math stuff. We're sticking to what's called the conceptual level. We will still bring in some math. If you're fuzzy on math, go hit up Khan Academy or any other tool, buff up on your math. Math is awesome. At first, it kind of hurts, but when you see the higher level stuff, it's just amazing. And then there's lots of YouTube videos that have awesome things. We're not going to watch so many of them because mostly the physics involved in a lot of what they do is much higher level. And quite a few of these channels have more than just physics that they cover. And then disability, sport, and academic integrity, because it's required to be in there. Please, for the love of God, don't cheat. I hate having to report people for cheating. Okay, so getting back down to raw resources and being completely out of time. Top Hat Monocle. So go tophat.com. I was trying to not have you guys pay things, but the other 25% of your grade that's not the exams is this. Because the only way I can think, again, the thing which is not graded at all is the thing that slips when you're too busy. Which means all those videos you're supposed to watch outside of class, you're going to decide, oh, I'm not going to watch that. I'll just show up to class, listen to everybody else. I'll figure out what we're doing. Unless there's a grade attached. The best way I could think to attach a grade to that wasn't completely artificial is to ask you guys questions here in class. But if I'm just having you raise hands, that's not going in my grade book. So we're doing device-based clicker questions. So you need to have something with you that can either text or get on the internet in order to use this interface. So I'm going to log in really fast. I'm trying to not break past our time. So you just type in Idaho or full-on University of Idaho. You find us. Set up your account. And then you'll get in here. And I will have this thing up in class many times. And if I think of an interesting question, then I will just come over here and I will make the question right in front of us and then ask you. And so after you guys have entered our class code and you've gotten set up the first time, then you're done, you're set up. So on your device, this would pop up. And you would be able to choose your answer. If you're internet-based, then you're on a web page just like this. You just touch what your answer is. If you're answering by text, then you text in to this number with what your actual choice is. So it gives you an example of what your answer might look like over there. If you don't have a text or internet capable device that you can bring with you every day, talk with me, either right now after class or by email. This costs 24 bucks, which is much less than most textbooks do, so hopefully you guys are all good for it. But if you have a reason why you cannot do this, again, come and talk to me. It might be for some of you that I just have you writing it out on a sheet of paper and bringing it up to me whenever we do one of these. But for the bulk of you, you've got a laptop or you've got a cell phone that's a smart device, or you've got a cell phone with unlimited texting, and so you can do this and it gets you in on a grade book, and I can ask you questions to verify you watch the videos, and I can stop doing all this raise your hands, rough idea. I can actually ask a question, get a poll. Yes?
When do we need to have that set up by?
Please have this set up by Wednesday when we meet again. So talk to me by email if there's any issues, and I can tell you what I can work out.
Is that course code on the...
Cool. That's on my syllabus, yeah.
Syllabus? Okay, that's what that top hat is?
Yeah, right here, top hat code.
Okay.
And I really should have had a link to the actual website. That's an oversight on my part. That's probably why so many people haven't signed up.
You can get to it on BB
Yeah, I've got a link on BB Learn. Yep.
Alright, so the top hat link is on Baby Learn?
Yes, I put a link to Top Hat, and I put a link to something else, but I can't remember what now. I think the OpenStax textbook.
All right. Cool. Thank you. And so we just go online and pay for it online right there?
Yeah, you can pay for a 4-month access for $24, or you can do like $72. You get there's a couple other people on campus that use it, but I don't know who. So it might be worthwhile to do the lifetime, but probably not so much. It's one of those things where the third time you're exposed to this, then you kick yourself and say, well, it would have been worth it. Okay. But I don't think that there's so many people at university using it that you'll have more than 3.
Right, I was just trying to do it before class, and so the app that it comes with, we just put in that course code.
Yes, it should ask you for a course code before it ever asks you to pay, because some courses cost different.
It said add course to either find it by teacher's name or course code, so I just wanted to make sure that was the code I needed to get.
Okay.
Is there a different way to navigate it? Because these buttons up here don't work for some reason on my phone. Like, should I just download our app?
No. Oh, you're on the website.
Yeah, I'm on the website.
Yeah, try the app. The app seems to work pretty well.
Okay. Because there was a little pop-up that was like, it's blocking something, and I ignored it, and now I can't, because I can't click on...
Does this have an incognito?
Now it's working?
Of course. Sometimes things on the edge of your screen, they try to interact with the screen instead of what's on the screen. So just having it not on the edge can help too.
Okay.
That might be what the difference is right now.
Oh my god.
All right. All right, I need to climb up here for a moment. Oh, sorry. I was trying to not step on it.